In this problem, a cannonball is projected at an angle of 60 degrees with an initial speed of 15 meters per second. We are required to calculate the maximum height and the horizontal range. So we have the problem illustrated here. So a ball, the cannonball, is launched with an initial speed v0 at an angle of theta, which is equal to 60 degrees. Now we are required to calculate the maximum height. We don't know the maximum height, and we are required to calculate the range. Now, in calculating the maximum height, you could do this in probably less than a minute, but I want to show you a process that will help you in analyzing and solving almost any problem in projectile motion. But first, when you look at this diagram, I have kind of annotated three areas. You have, this is the initial point, which is the origin. I'm just gonna denote it as O. We can resolve the initial velocity v0 into two components. You have the velocity in the x direction, which is vox, and you have the velocity in the y direction, which is voy. Now, if you pick, let's say, 3 points, these are three important points. For example, at A, the velocity at point A is directed like that. That is v at point A. It has an x component. This is vx, and it has a y component. This is vy. Now at point B, the velocity is directed like that. This is vx. So the velocity at B is strictly just the horizontal component. Keep in mind that the vertical component at B is 0. B is the maximum height. So in other words, at maximum height, the vertical component of the velocity is 0, but the horizontal component is not 0. The only time in which both the vertical and the horizontal velocity are 0 is when the particle is projected vertically upwards. At that time, at maximum height, both Vx and Vy will be 0. Now at point C, the velocity is directed like that. This is V. We can resolve it into two components. This is Vx and this is Vy. What do you notice? When the ball is ascending, the vertical component is positive, but when the ball is descending, the vertical component is negative. But at all times, the horizontal component is pointing in the positive directions. Now, the same thing happens at the point of impact. So let's write down the initial conditions here. The initial conditions. What are the initial conditions? The initial conditions are the values of x, v, and a when t is equal to 0. So what happens at t equal to 0? We know that x is equal to 0. We know that y is equal to 0. We also know that vox is equal to v0 cosine of theta. We know that voy is equal to v0 the sine of theta. Similarly, ax is 0 and ay is equal to negative g. I have basically assumed here that the upward direction is assumed to be positive. The upward direction is assumed to be positive. Now for some of you, you may be confused as to how I kind of smooth up this, both the vertical and the horizontal component. If you look carefully right here, you would notice that we could actually form a right angled triangle, in which case you will have, this will be V0, this is VOX, this is VOY. This angle right here is theta. So if we use Socotoire, the sine of theta is equal to opposite, which is VOY divided by V0, which implies that VOY is equal to V0 sine theta. Similarly, cosine theta is equal to VOX divided by V0, which means that VOX is equal to V0 cosine theta. So this actually explains the origin of V0 sine theta and V0 cosine theta. Now, we have to write down the equations for the horizontal motion and the equations for the vertical motion. Generally, we know that V is equal to V0 plus AT. That means that Vx is equal to VOX plus AXT, which is just gonna be V0 cosine theta plus 0. Why? Because the acceleration in the x direction is 0. In other words, Vx is simply V0 cosine of theta. Now in the same manner, Vy is equal to VOY plus AYT. This is equal to V0 sine theta minus GT. So what we are seeing is that Vy is equal to V0 sine theta minus GT. So these are the first two important equations that you have to write down. It's important. Now the next will be the positions in the x and in the y directions. Generally, we know that r is equal to r0 plus v0 t plus 1/2 at squared. So this means that in the x direction, you have we have x equal to x0, which is equal to 0, plus v0 xt plus 1/2 axt squared. This is 0. So this would mean that x is equal to v0 t cosine of theta. This gives us the expression for x along the horizontal direction. So y will be equal to y0 plus voy t plus 1/2 ayt squared. This would mean that y is equal to v0 t sine theta minus 1/2 gt squared. This gives us how the position varies in the y direction. So we have a set of 4 equations that we can use in analyzing almost any problem in projectile motion. The first, you have Vx equal to V naught cosine theta, assuming that the angle here is subtended with respect to the horizontal. If it's subtended with respect to the vertical, it's going to be V naught sine theta. So we have Vy is equal to V naught sine theta minus gt. And then you have x equal to V naught t cosine theta, and you have y equal to V naught t sine theta minus gt squared minus 1/2 gt squared. So with these four equations, I can guarantee you that you will solve almost any problem that I will give you in this course. So let's go ahead and calculate the maximum height. So the first question is, we need to determine the maximum height. So what do we know happens at maximum height? At maximum height, Vy is 0. What does that mean? That means that V naught sine theta minus gt max is 0. So the time to reach maximum height, T max, is gonna be equal to V naught sine theta divided by g. So this expression here gives us the expression to calculate the maximum height. So our maximum height becomes 15 meters per second multiplied by the sine of 60 degrees divided by 10 meters per square seconds, and this will give you about 1.3 seconds. So we will use that 1.3 to substitute it in the equation y equal to V naught t sine theta minus 1/2 gt squared. So that becomes 15 meters per second multiplied by 1.3 seconds, the sine of 60 degrees minus 1/2 10 meters per square seconds, 1.3 seconds squared, and this will give you about 8.45 meters. So this is Y max. This is Y max. Another way that you can actually do this is to take this expression and substitute it in that equation. If we do that, we will have here Y max will be equal to V naught bracket V naught sine theta divided by g multiplied by sine theta minus 1/2 g bracket V naught sine theta divided by g all squared. This becomes V naught squared sine squared theta all divided by g minus V naught squared sine squared theta all divided by 2g. Notice that one of this g will take care of one of this g, and we're subtracting a 1 from a half, so this means that Y max is equal to V naught squared sine squared theta all divided by 2g. And if you substitute what we have, you will have the same answer like before. Now, if you had used this formula, I will still give you the same points compared to the person who would have used the approach that I showed you before. It really doesn't matter. Now, I like to show you all the approaches so that you should make your choice as to what is comfortable for you. Now, the next part is for us to calculate the range. The range is a horizontal distance. As a matter of fact, the range is defined as the maximum horizontal distance. The maximum horizontal distance. Generally, the horizontal distance is given by V naught T cosine theta, but the range R is equal to V naught capital T cosine theta, where capital T represents the total time of flight. Now, when you look at the part of a projectile, you realize that the time to reach maximum height is the same as the time for the ball to impact on the ground. That means that the time of flight, the total time of flight, is 2 times the time to reach maximum height, which is just gonna be 2 V naught, the sine of theta, all divided by G. This gives us the time of flight. Therefore, R will be equal to V naught bracket 2 V naught sine theta, all divided by G, multiplied by cosine theta, which, if you simplify, R will be equal to V naught squared sine 2 theta, all divided by G. So this right here is the expression to calculate the range. So if we feed in the values, the range will be equal to 15 meters per second, all squared. The sine of 120 degrees, all divided by 10 meters per second. And if you do that calculations, it winds up to be about 19.5 meters, and that gives you our range. Now, before we go, remember that the velocity v at any time t is vxi plus vyj, which essentially is just v naught cosine theta I plus bracket v sine theta minus gtj. Now, if I ask you to calculate the speed at any time, the speed is just the magnitude of velocity, which is given by the Pythagorean theorem. This is vx squared plus vy squared. Now, this will come in handy pretty much soon. Thank you, everybody. I hope you did enjoy this. If you have any questions, please do not forget to ask your questions in the discussion forum. I'll get back to you there pretty much sooner. Thank you. Bye-bye.